Hi and welcome back. In this video, we're going to look at how we can print our tree. And as part of printing our tree, we're going to have to look at something called recursion. Recursion is something that can be quite tricky to really fully get your head around, but it's a very simple concept in fact. Something I'll say about recursion, and also binary trees, is that you won't be using these very often in your day jobs. I, for example, work in web development. I do a lot of sort of back-end development and front-end with JavaScript and so forth, back-end with Python. And I have never used binary trees or recursion in my day job. Nonetheless, it's something that can pop up in coding challenges, interviews, and so forth. So it's good to know about it. And it's also in software, it's used behind the scenes, like in databases and things like that. So it's useful to know about it. That's why we're sort of going through it. But don't worry too much about fully getting your head around all the use cases and how you use them extensively. It's just not really worth it. Although I will give you some more resources in case you're interested. In order to traverse in order, we are going to use recursion. So let's first in order recursive. I'll type out a wee method here. I'll type out a wee method and I'll explain exactly what's happening. And also, as part of this, I'll explain, of course, what recursion is, because I know that we've not done that yet. What we've done here in this inorder method is it doesn't take any arguments, but it calls another private method. In Python, by the way, I'm not sure if I've mentioned this, but when your methods and your variables start with an underscore, that means they're private, or you don't want other people calling them. So we call this private method inorder recursive with self.head as the argument. Self.head becomes current node in this inorder recursive method. So this inorder recursive method, all it's going to do is it's going to say, if the current node is none, then we're going to return. Okay, we're going to terminate the method. If a current node is none, we're going to terminate. Then what it's going to do is it's going to say call itself, but with current node dot left. Okay, so as you can see, this inorder recursive method calls itself. This is recursion. Recursion is when a method or a function calls itself. What happens when you call yourself is something rather interesting. And we're going to talk about it in just a moment. And then we're going to print the current node, and then we are going to call ourselves with the right node. Okay? So here's what happens when you do recursion. The inorder method calls self.inorder recursive. So we end up here. Now, Python knows that the inorder recursive method was called by the inorder method. It knows that. It keeps track of who called who. For example, so it can tell you in the stack traces in your errors. So it knows that the inorder method called us. We run through this, presumably we pass, and then we call ourselves again, inorder recursive. So we go back to the top. Now current node is a different node, but we know that we got called by inorder recursive. So Python knows inorder called inorder recursive called inorder recursive. Then we go again. If we call ourselves again, Python now starts constructing a collection of how did these calls go? Who called who? What were the arguments or the values of these parameters when each method was called? Okay. So eventually we reach the leftmost node of the tree. We print it out. Then we go right. And eventually we sort of are at the right